Okay, I'm one of us. I'm Justin Rao. This is David Rothschild to my left. Today we're going to talk about consuming sports, a little theme we developed, information, interaction, innovation. So it's important when you're giving a talk for a big company like Microsoft, as many of you know, it's important to distance yourself from what you say with a disclaimer. So I put it here. I hope everyone can read that. But since Microsoft's a good, nice company, I'll enlarge it for you. So this talk represents our views, me and David's, not necessarily those of the Microsoft Corporation. While the talk does feature some ideas that are currently in development, it should not be viewed as a short-term product roadmap. I also want to call out my boss is in the front row. About 70% of it does represent her ideas. So especially the stuff you really find distasteful. Her name is Jennifer Chase. She is right here. You can approach her later. She also decided to hire both of us. So if you think we're sort of not that smart and full of ourselves, she's the person to take it up with. All right. Now we got that all the way. So what's this talk about? David and I both do work on aggregating information so we can understand the world better, and we both really like sports. And one of the things about sports that I find most exciting is that Americans will engage deeper in a statistical way with sports than anything else. You can meet someone on the street, they say, I don't understand probability, but they know what a batting average is, right? They say, I don't understand percentages, but they understand pass versus run in the NFL. And so what we're really excited about sports is something you can get people to engage with the math and science in a way they feel very comfortable, in a topic domain they feel very comfortable with. Fantasy football is incredibly popular, and is essentially, you can play it if you just know math, or you can play it if you know football, and it's one of the great things about it. So from a research perspective, that's what gets us excited, that's why we're asked to give this talk. And what this talk is about is how we consume sports. And so we start with a basic observation that the way we consume sports today is pretty much not that changed from when television was first invented. We film the game, it goes to you, you consume it, you're just producer to consumer, right? So you have basic content and a viewing event. And that's sort of where we're at. In our themes, information, innovation, interaction, the information is slow in general. Well, of course it's relevant to the game you're watching, but it's the sort of the basic stuff. And the interaction, importantly, is producer to consumer. So it's CBS to you, sitting on your couch, right? And notice how different this is from even like the first generations of games online or something like this, where you have a much more rich interactive experience. Another way to visualize this is the information you get when you're watching, say, a football game is the score and how much time is left and the down and distance. And the interaction you get is Chris Collinsworth telling you stuff that's in his head, right? And Chris Collinsworth is my favorite announcer, and I really do like Chris Collinsworth, but that's the level of interaction. You have two guys sitting in a booth sort of talking for 3 hours. And that, as engaging as these two guys could possibly be, I think maybe we can strive to do it a little better. And most importantly, as a consumer, it's pretty hard for you to interact with them. If they say something stupid, you can just get mad, and that's about it. So in this talk, we're going to build up how we're going to make this consumptive environment for sports more engaging. And the first step is what we call incorporating fundamental modeling and statistical methods to provide advanced statistics in real time. So what does this do? It takes that basic content, which is the game, the down and distance, and this sort of stuff, and adds real-time game logs. So game logs have been available since about 2003, and they basically digitize what's happening, right? With real-time game logs and statistical methods, you can get advanced statistics for what you're watching. Now I'm going to give you an example. Advanced statistics might not sound that sexy to you. Here's an example of something that essentially would be unwatchable without advanced statistics. This is poker on ESPN. Now, poker on ESPN is very popular. The advanced statistics in this case are the percentages of the guy winning the hand. So one guy's got 2 sevens, he has a 68% chance to win. This has made poker watchable, right? Without these advanced statistics, without doing the math behind poker to tell you the odds of winning, this is just a few guys sitting around the table with cards. You don't know what the cards are. They're putting chips in. You have no idea what's going on, and it's the least entertaining thing possible. I mean, I can't imagine anyone watching this without those numbers, right? So poker has a little advantage. Everything on ESPN is tape delayed, right? So they can use their offline math model to provide this, but advanced stats make the game watchable. So going back to our, say, football, advanced statistics might make it a little more engaging. But what's it using there? It's really using data that's been around since about 2003. Game logs have been around since 2003. And we're still in that producer-to-consumer interaction. We have a richer experience. So we might make the game more watchable. But we still haven't fundamentally changed the way we're consuming sports. But it will provide a good baseline. Step 2, we're going to talk about this throughout how, with some examples, is we'll try to leverage social channels. So we'll take this sort of diagram as we see it now, and we'll add in something like Twitter. And how is it currently being the current social implementation? Well, take these arrows, the weight of these arrows to represent sort of how much information is flowing, and the content's flowing to the viewer. We'll add in Twitter, and then sort of a really tiny amount of information is flowing back to Collingsworth, and then Collingsworth is like putting a tiny amount of information into the game. So really like one in a huge number of users gets featured, and there's limited usage, and then Collingsworth will say, well, David Rothschild said that was stupid, you know, and that's amount of engagement. This is, you know, this shouldn't be compelling. This is pretty, I mean, probably the announcers were told, hey, every 10 minutes you have to mention some Twitter guy, and they'll say that's stupid, and then, you know, that's what he says, right? So it's not particularly engaging. As a user, I'm not particularly motivated to participate because it's only 1 in a million users that gets featured, and they'll probably just feature some, you know, pseudo-celebrity anyway. Okay, so although it's currently being used, the implementation sort of lacks all the things that make an engaging experience. The flowchart for that is we call it light social. It's a light interaction because the data collection is hand-picked data, right? It's not aggregated in any meaningful way. There's no science behind the aggregation. And it's still producer to consumer except for that 1 in a million consumers that gets to talk to the producer. The innovation, it's data that's been around, say, since year 2008. The information might be slightly improved to get the pulse of what's going on, but it's only a slight improvement. This latency cycle, this 1 in a million thing, creates a barrier to engagement and information aggregation. So when you're watching the game, you're really not getting that much more information because one user said X than you would if Twitter wasn't featured at all. And then as a user, you really won't tweet at, you know, CBS Sports because, again, your incentive to participate is incredibly low. Where's the future going? So if this is where we're at now, and we can say, hey, with the technology we currently have, viewing sports now looks pretty pathetic, frankly. So 1 in a million users gets featured, Collingsworth says user X said Y. This doesn't seem that great considering how interactive other forms of entertainment are. So if you think of the Xbox platform, Xbox Live, you're playing Halo, everyone's interacting completely in real time. Very low time latency, and a huge community interacting, and these online gaming communities have this interactive cycle that really makes those games that engaging, why gaming consoles have really blown up. So in the future, what we look at is the viewing experience has information in real time complementing the experience, comes to your home via, say, something like Xbox, and you can interact with the broadcasters not just through Twitter, but through something like Xbox Glass controller, but with high weight and low latency. Okay, so what will this look like? Well, we're thinking things like live polling and aggregated social. So live polling and aggregated social give you heavy interaction and importantly give you gamification. That generates big data. The tweets, as we'll talk about, David's going to go through, light social and that sort of interaction generates a lot of data. It's big data, but it's not very useful. So big data is this sort of theme that caught on in Silicon Valley, and it's highly misleading in some sense. It's like the size of your data pile indicates how valuable it is, and this is a dangerous notion. Really, it's the quality of your data times the size of your data. And when you have a great incentive to interact in an intelligent way, you get more data, but you get high quality data, right? You don't just get a mounted tweets. If you look at Twitter, one of the deep, dark secrets of Twitter is initially when they started doing their trending is they had to de-Bieber the trending topics. Because the day that the Tahrir Square riots happened, Bieber got a haircut. And I believe there are more tweets on that than Egypt. But if you de-Bieber it, then you're good. So the problem is they have a lot of data, but you got to de-Bieber it, you know? That's an actual term. And it was controversial at the time because they had this sort of proprietary black box, but what they wanted to do is make it relevant. It was actually good they were doing that. Otherwise you just get, okay, I care about trending topics. Now I know Bieber's hair is slightly blonde and slightly cut, and oh, by the way, there was a takeover of a country, you know? And so with heavy interaction, the gamification, you get high quality data. To do that, and why researchers have to get involved, is to get the insights you need, you'll use not just basic statistical techniques, but techniques from data mining and machine learning. Going back to our themes, the information will have a low time latency, it'll be relevant and personal. With live polling in a, say, NFL game, you're going to have data that only now exists in sort of the current present. It's very innovative. The interaction will be producer to consumer as it always was. It'll be consumer to producer because we'll be aggregating all those votes and polls. Everyone gets to participate. But very importantly, it'll be consumer to consumer. So gamification, if I'm playing a sort of a game with you where I'm going to predict if they get the first down or not, or if they should go for it on 4th down, I can play against you. We can cut the producer out of the loop entirely and have something like more like fantasy football, which is consumer to consumer. Of course, fantasy football is sort of very long time scale, right? On Monday, we compare who won. What we're talking about here is very short time scale with an interactive experience. In some sense, the genius of why people enjoy this sort of thing is it replicates what you wish you had. I always wish I was watching a football game next to my father and my brother. I like yelling at those guys, and they're pretty smart, right? Just like the reason Facebook and Instagram were a genius with photo sharing. I love sitting someone next to them and make them look at pictures of me. I actually really like to do that. Apparently, everybody really likes to do that. And Instagram and Facebook let you do that at scale, okay? So in some sense, we're just leveraging some tendency people already have and providing that interactive experience that crosses the physical distances that now separate a lot of people. So as we said, how are we going to get this off the ground? One of the things David's especially an expert in polling and aggregating social information is you have to solve that big data conundrum. If you have a huge pile of data that's low quality, you have two solutions. One is you can develop data mining technique to find the high quality data. Second, which dovetails in, is ask better questions and elicit higher quality information. So the first step in doing that is to get everything off the ground with fundamental modeling. So I'm going to show you some ways we can use, this is the advanced stats part, so we can get all these questions, all these games off the ground with some fundamental baselines. So here's some modeling basics, just to get our terminology. A model is a simplification of the world. It takes inputs to the model in sports. Again, I love talking about sports, we can all understand this. Input to the model are things like score, time remaining, players in the game, and so forth. And it estimates some output of interest. That's all a model does. People use the word model, they act like it's fancy. This is what it does. It simplifies the world, takes things in, gives you output. Fantastic. It's like a Camry. In my head, that was funnier, and Jennifer thought it was kind of funny, but I guess not. All right. Example of outputs could be the probability of scoring on this drive, making the field goal, getting the 4th down, winning the game. Or could be any action you could think of, right? It could be making this particular shot. And in fundamental modeling, the key is that we use past data to sort of calibrate this input-output mapping, right? So we want to say, how do inputs track to outputs? Well, we'll use past data to calibrate the model, to build the model. To build a mathematical function that relates the inputs to outputs. That's basically what modeling does, and I think if explained in this light, it's pretty easy to understand. In this setting, fundamental modeling leverages historical game log data. I mean, game log data allows us to get off the ground running because it's digitized what's happening on the court or on the field. And there's an important caveat here, and why sports fans gets all aggravated when you mention fundamental modeling and advanced stats, and I have papers in this field, and I get emails from what I call crazy people all the time. The problem is it assumes the world is stable. And what I mean by that is using historical data to tell what's going to happen in the future. And so that's going to work insofar as the past is going to map to the future pretty well. But let's say a player is getting older. Let's say this situation has a lot more pressure than other situations. Perhaps the world isn't stable. Perhaps something like this particular moment is different. The fundamental model is always going to miss that. Takes the current game conditions as the inputs, and they are available in real time. And again, using these historical relationships to tell what those inputs will map to outputs. And in terms of how this information will be relevant and improve the viewing experience, well, they're tailored to the situation. So it's, for example, if it's a 4th down, we can say what's the probability of making it, getting the first down. If that happens, what's the impact of getting this first down and winning the game? How important is this first down? And if we miss it, what's the probability the team will come back and win? So these are all outputs of sort of slightly different models tailored to the situation of a team facing a 4th down. And we're going to talk about the situation a lot. So you can build many models, but again, in terms of how the data is presented, you'll tailor it to the situation. Here's some examples of what some fundamental models can produce. And one of the things I like to highlight here is that this is some of the work that I've done. And when I presented this to experts in the field, a lot of times it was news to them. So although you might say, how can providing advanced statistics really inform the fan? It's kind of like that poker example. You might know 2 7s is better than a queen and a 6, but you don't know how much better. It's actually interesting to know how much better. In sports, it's actually even more interesting because in poker, the probabilities are stable. In football or in basketball and all these sports, things are changing, right? The high pressure moment, certain players might get better or worse. So here are some examples. This is the probability. The blue line here is so the y-axis this is the game 4 of the 2011 NBA Finals. And the y-axis is how much Miami is winning the game. And the blue line is going to be tracking the score. So at the start of the game, they're down by 5, then they go up by 5 at the start of the first quarter, and so on and so forth. The red line corresponds to the right y-axis, gives the win probability for Miami. And so what you can see here is that the game starts out, the red line starts out, the game's pretty much 50-50. The red line doesn't move around that much. Early in the game, the score doesn't really affect the win probability that much. Then late in the game, say in the fourth quarter, when they're leading, their win probability goes way up. And when they start losing late in the game, the win probability goes way down. And then what I'm showing you here is really Dwayne Wade was shooting free throws, and the blue dots show he makes a free throw. It goes up to a win probability of 30%. He then misses the next free throw, that's where it goes down, and then they end up losing the game. So it shows you how important those free throws were. It goes up, it assumes he's going to make the next one, he misses it, they turn the ball over, and they lose the game. So in real time, this gives you the chance, in that moment, it showed you that was probably the most important shot Dwayne Wade took in his entire career. Okay, that's what we think. It changed the chance of winning an NBA Finals game by about, if he had made the second one, they would have gone from a 15% chance to a 50% chance of winning. Having missed the second free throws, goes back down to 15%. An unbelievable change. So fundamental models can highlight the most important aspects, but they can also give a baseline for the interaction. Here's an example of what fundamental modeling can output. This is the output of a model. On the y-axis here is the chance that a basketball team will win the game. On the axis that's sort of going towards me is how much time is left. And on the axis that's going with y'all is how much the home team is leading. And what you can see here, it's a little hard to see, but you can see as you get closer and closer towards the end of the game, the lead tends to matter a lot more. But I can cut this graph in a different way. I can say the blue line here is the lead required for a 90% chance of winning the game. What does this blue line tell us? Well, we can look at a few points. What it says here is that a 14-point lead at the half is about as good as a 10-point lead at the start of the fourth quarter. It's about as good as an 8-point lead with 5 minutes remaining. So this is just the information in that last graph summarized the way we can consume. The point being here is that first graph, that nice S-shaped fancy thing, it looked pretty fancy, and I made that, and that's pretty, well, actually my co-author made it. And it's pretty fancy, but really you couldn't really see much in it. What this is showing you is something a fan can interpret. If you told a fan, listen, what would you rather have, a 10-point lead at the start of the fourth quarter or a 14-point lead at the half? Be interested to hear what they would say. It's a good interactive question. Now, what if the statistics...
Question.
Yeah.
Which world sports are you referring to?
This is NBA basketball.
Yeah, but half of the people here are outside from the USA. So, I don't know much about basketball. I don't know how many quarters it has.
Okay.
I don't know what a free throw is.
Okay. 4 quarters. If it's a quarter, it's always 4.
I find it pretty obvious.
Yeah.
My point is, this is so specific to the United States. It's not even funny.
Okay.
You know, if this was soccer or tennis or something,
yeah.
I should have.
So tennis is a good one. Tennis is easier than soccer. So. A few answers. One is that the examples throughout will be themed towards American sports for 2 reasons. One is that our background in those sports, our domain expertise is higher, and so we feel more comfortable with our fundamental modeling and what we can do there. The second is in terms of our integration with the platforms, the deals that, say, the company has made with the NFL and partnerships like so forth like that, typically focus on North American sports first. In terms of the modeling techniques, there's really nothing that specific. A sport like where it gets difficult is the following. A sport like basketball is probably, or baseball is the easiest because you have a lot of repeated interactions, a lot of pitches, a lot of shots, so forth. A sport like tennis, in that realm, a lot of repeated points, a lot of points, a lot of data to churn with. A sport like soccer, although the data is getting better in terms of there is data with like tracking players where they are on the field, you have more discrete environments. So you have 1 or 2 plays affects the game outcome fundamentally, and you have less sort of law of large numbers on your side. So things are more challenging there. And there is a lot of work on predicting soccer games, but it's I would say less statistically, it's more statistically challenging than what we're going to be dealing with. And the third answer is that if any of the examples we have kind of cut a little too fast with the sports, it's partly because we have a time constraint and we just can't go through them. So I think in any case, anyone can sort of engage the following question. Say you're a fan of basketball, like say 40% or 50% of Americans are. This is something you have in your head, and you have some kind of background knowledge of what's important and what's not in terms for a team, but you have an opinion on this. You have actually a stronger opinion on this than you probably do a lot of things in the news. And when you present something like this in front of basketball fans, they will have a prior and they will sort of have an opinion that I think they have a desire to express. And also another thing is that this relationship, although it's stable on average, is probably always wrong in its specific application. So based on a given matchup, based on how the teams are playing, a 14-point lead might not be as good as a 10-point lead at the start of the fourth quarter, or an 8-point lead. So this relationship is sort of, fundamental models give you the long-run patterns, but miss the short-run intricacies. And that's where the advanced polling and the real-time data analysis with the interactions can improve both predictions, but also why they're fun, why they can be beat. And in some sense, this would always be wrong. The word residual on a model is what we use to capture how often the model is wrong. And all models have some residual, which is some way it's wrong in a way we don't quite understand. And hopefully we kind of suck up some of that things we don't understand by the users out there with information. So another thing, another graph I'll show you is this is the probability Kobe Bryant will shoot the ball. He plays for the Lakers. If he's on the court, he's probably one of the best players in the league. What this graph shows you is that Kobe Bryant is very, very likely to shoot the ball when the team is losing, and especially when the team is losing late in the game. Okay, so if you're watching the game, this could say if they're down by 10 with 2 minutes left, it says actually it's a 41% chance he's going to shoot the ball. Conversely, if say they're up by 10 with 2 minutes left, it's only about a 25% chance, or 26% chance he'll shoot the ball. This information is provided. When I presented this information to people in the basketball world, coaches, they were surprised how big a difference it was between winning and losing the game. This information provided to users and get feedback on whether he should shoot or whether he shouldn't shoot, and so on and so forth. So this is the kind of information you can get with the fundamental modeling. Okay, so to close down fundamental models, before I hand off to David, fundamental models help form a solid baseline, and it's only a baseline because they fundamentally assume the world is stable. They can provide advanced statistics the fans can consume, but importantly, and this is actually a feature, not a bug, they often draw criticism from fans. So an example is that models say teams should go for on fourth down more than they typically do. This sort of disagreement of what the stats or the geeks say and what the fans think provides a great opportunity for interaction, see who's right and who's wrong, and also further in that sort of circle of interaction we talked about. So I'm going to hand it off now to David. David, take it away.
Thanks for warming them up, Justin. So I'm gonna jump into the next data source that we were discussing in the kind of circle that he put in the beginning, which is social media and online data. And social media and online data, let's think Twitter and search. It's very alluring and very, very exciting for people who think about how the world is going to change and what people are going to see and what people are going to consume and how they're going to understand the world. And they think a bunch of things. People think, well, wow, it's really cheap. It just exists. It's out there. It's free, basically. It covers everything. I mean, people talk about everything from soccer and basketball and football to what they eat, to where they go, to movies, to the economy, to politics. It seems like all domains are covered. The timing, it updates all the time. People are always tweeting. People are always searching. People are always adding more into the pool. And it seems to talk about what people are interested in because people are publicly revealing it, or when they're searching, they're privately revealing it. And it kind of indicates whether or not they like things. There's a sentiment involved in it. So this seems like a really awesome thing. But then when you start breaking it down, you start realizing that this data is really difficult. And this goes to what Justin was saying before. You have this trade-off. Social media and online data is huge. It is massive. It's mind-bogglingly big how much data is being rolling through these conversations. But it's really low quality. So, well, first of all, it's not really free, right? So if you really want to be talking about this during broadcasting, so if you want to show something up there within seconds, there's proprietary streams that you need to cut into. Secondly, the domains are not nearly as deep as you think they are. So maybe people are talking about soccer, maybe people are talking about the soccer match you're watching, but people aren't constantly talking about that player's position or that that one pass, because there's only so much people can talk about. And when you start digging in to what you may be interested in, it may not be there. Timing. There's a latency. It takes time to write a tweet. It takes time to go search something. People don't do things immediately. And one of the hardest things we find, especially with sports, is that there's a timing on the wall, and then there is a timing on the field. And matching all of that stuff up is actually quite difficult and complicated, because we know when a tweet went out, we know when a search went out, but always matching that up to what were they talking about? Were they talking about that pass or that pass? Not always so obvious. And then there's this question of the question. What are people talking about? So we know that in search, there's a couple of things people are doing. They're looking for information, they're finding directions, they're shopping. It's not even so obvious in social media data. They're answering a question, but it's not sure what they are all the time. And so let me focus in on that and kind of explain why social media data and online data, why it's so tricky. So these are from two major websites that we do not own, in which they were talking about what's going on into the Super Bowl. Super Bowl is the biggest championship in American sports. It happens once a year. It was between the Seattle Seahawks and the Denver Broncos this year. And on your left, you see search counts. How much people searching about the two teams? These are raw counts. People were searching more about the Seattle Seahawks. On the right, you see social media accounts. This is actually Twitter. People were tweeting more about the Denver Broncos. This was published and widely read as something that's supposed to be interesting and maybe meaningful. To me, it's just raw data that ultimately correlates with nothing I care about except for how much people were searching and how much people are tweeting. So if you care about that, your answer is right there. It's awesome, it's done, you're perfect. But if you don't care about how much people are tweeting and how much people are searching for the sake of searching and tweeting, you've just learned nothing. I mean, really, not much. And I could show this again in politics, and I'm going to use politics a little bit here, and I just want you to think about politics as a really long game. And an American game that lasts about 2 years, the presidential election. So this is like, think about this as the fourth quarter, right? This is running from August 1st to November 7th, election day. This is looking at Obama, Romney, and both. So this is on the top. This is how much people were searching for Obama or Romney, or both Obama and Romney. And on the bottom is how much people were tweeting about Obama, Romney, or both Obama and Romney as a percentage of overall volume. And there's a couple of things you see here immediately. So when I said domain, right, everyone's thinking, oh man, people must be talking about politics a lot. It's right towards the end of the election. But even just looking at English language search and English language search from America, and on the bottom that's this English language tweets, you're talking about a fraction of a percent of how much this conversation is actually about politics. So in the dotted lines are major events. The first is the RNC, the second is the DNC, so these are the big conventions, and the other three are the three main debates. You see spikes during it, but they're not huge. And then you think about this question, like what question are they answering? Well, baseline, Obama's president, people are talking about him more, because there's also presidential stuff they're talking about, right? And then you see spikes, so when the Republican convention's going on and it's Romney's convention, people talk about him a little more than the president. They search for him almost as much. There's some weird spikes. But what does this mean? It's not entirely clear. This is just raw data. This should be ultimately meaningless to you unless you really care about it for its own sake. So then you could start throwing sentiment on top of it, and I show this slide just thoroughly to mock the people who did this. It's a major company that just got bought for a huge amount of money. I am I believe myself to be one of the world's experts in social media data, and I know I'm one of the world's experts in forecasting the Oscars, the major event of the movies and the major awards event movies. They published this in 2013 for the Oscars. I have absolutely no idea what this means. All I know is that they were very proud of it. They got a lot of positive press about it. Everyone thought it was pretty. It has something to do with sentiment and social media, and ultimately it is just garbage. I mean, absolute garbage. So we want to move past that. And the way that we move past that is we start treating social media data and online data like it was a gigantic poll. So in a real poll, you go out and you interview a very select group of people. It's random but representative of the population you want, and you ask them the question that you want. And then you have an aggregation method that you utilize to then provide market intelligence. It's something meaningful to your end stakeholders. This is like a gigantic poll where you don't know who's talking, you don't know a question they're answering, and then you need to figure out, for this domain, what's the best way to aggregate it up. Okay? So right off the bat, you can see there's a lot of extra data here, right? Because essentially, to compete with the poll, you need to just totally look deep inside this data and either mine a very small portion of it, or as Justin says, find some very creative techniques to make it sing, make it useful. And so I'll start out by saying that what we found is that when it comes to the people who are on it, when you start identifying it, you start learning some interesting things. You start learning that the ratio of men to women, of age groups, of geography, this fluctuates wildly. Now, you would think, oh, it's just not representative, but it's stable, and if it's stable, then you could debias it, but it's not stable. It actually moves in a way that when events happen that you care about, the numbers dramatically shift. And the reason why is pretty obvious. It's because during a big soccer match or a big football game or a debate, those are the 3 lines in there, or the first 2 lines are the conventions, there are 3, 4, 5, 6 magnitudes more people tweeting or searching or doing something. There are so many more people, and for magnitude, sorry, this is 10 times, 20 times, 30 times, that's nothing. This is 100 times or 1,000 times or 10,000 times or 100,000 times as many people maybe talking about Arsenal during Arsenal soccer match than they're talking about Arsenal the day before or the day after. And so this is a completely separate group of people. And so if you start thinking about, is this a stable way of looking, you're not going to get it. You need to debias those people in very creative ways, and requires knowing a lot about them. So you can do that, it's doable. But then there's this question. What question are they answering? And what we realized too is that not only is it a different group of people, they're answering a different question. So I wanted to highlight it through a really cool chart from a forthcoming paper I have, in which we just plotted the amount of tweets that had URLs attached to them. And we plotted it across the presidential election, and what you see are these dramatic drops in the percentage of tweets with URLs on them during the major periods of the election. So if you looked at the first debate that happened on October 3rd, this was the most pivotal moment of the election. Obama had a terrible debate. He thoroughly embarrassed himself, and it was just this tremendous disaster for the Democratic Party and the election, and though he eventually came around and won. But when you look at it and you're trying to say, what are people saying during the debate? So you would think, this is during the debate, this is exactly when you want to harness this data and answer this question about what are people saying. They're answering a totally different question than they were the day before the debate or right after the debate. If you break this down by hour, it's even more dramatic. I don't have a big enough screen to show you the drop. And the reason is because they're just answering different questions. And so you need to overcome that, because looking at social media and looking at online data, it's like I was having a poll, and then I had like 10 people one day, and I asked them question A, and then I have like 10,000 people the next day, and I asked them question B, and then I have like 1,000 people the next day, and ask them question C. It's tricky. Now, we can debias it, we can get some leverage on what the interest levels, but we can also accept that there's just certain questions that are relevant that they answer and certain questions that they don't answer well. And it's to utilize the data to answer the questions that it answers well. So one thing is you can debias and answer these questions about interest levels, but another thing you can see, what words are they attaching to their statements about different entities. And from that, you can learn a lot about the flow of conversation. You debias this to the general population or the population you care about. And I did this on the top here. This is looking at a combination of searches and tweets during the convention, during the 2012 election. And what you see here is the evolution of terms. And they're only meaningful if you have domain knowledge. This is what makes it tricky. Because without domain knowledge, if that gentleman who was in the crowd before doesn't know much about the 2012 US election, it's not going to make any sense. And if he doesn't know anything about football, the bottom stuff's not going to make any sense. But that's what is tricky about sentiment. That's what's tricky about pulling this stuff from social media data, because it's different for different domains. On the top, on September 11, 2012, there was an attack on the American embassy in Libya. It popped up on social media and search. It was a big topic for a few days. It drifted down. And then towards the end of the election cycle, the Republicans brought it up again using this term Benghazi, which was the city the attack was in. And you could see this evolution. It was really in, and then it dropped down, and then it came back up. It's that domain knowledge allows me to pull this and say, this is something from this data that actually makes sense. And this is a dramatization, just to make it really clear, of things that we've done and can do for the same thing for football. Now, interception is when the other team steals the ball as a turnover. A touchdown is a score. The fourth down is a pivotal moment in a game. That's all you need to know. And what you can see is where they clump together, what things last, what things have staying power. And those are the important questions that you can pull out. So you could really be pulling out, at the end of the day, you're pulling out interest. And that's what you can pull out from this data. Although this bottom chart is still very hard to make with low latency during a live event. So in short, you can't control the question in social media and online data. You can correct things for demographics, and from that, it's tough with the latency, but you can pull out some domain-specific information about what things people are interested in. And so if you think fundamentals provide baselines for likelihoods and social media provides a little bit about interest, let me jump into polling and prediction games, which are really going to start answering the core questions we care about. And so we're going to phrase this around the fourth down moment. And just to make it clear what this means and what's going on, here's a moment in a football game, an American football game. A team has the ball, and they have a choice. They either hand the ball over to the other team, where they punt it, and that hands the ball over to the other team, or they go for it. And if they go for it, they have a chance that they make it, and they get another set of downs, and they can keep playing. Or if they miss it, the other team gets the ball with better field position. It seems like a fairly simple decision. It happens all the time. But it's actually very complex to think, what do we want to know about this? And it's complex because there's just so many different questions you can think about. Should they go for it? What should they do? What type of play should they run? What are the different outcomes that could happen, and how should we compare them? And the way to really think about this is we're going to take a step back and think about it very methodologically. You think you have the ball, you have a choice between punting, giving the ball away, or running a play. And if you punt, with 100% certainty, the other team has the ball at a worse field position. If you play, there's a % chance that the other team gets the ball at a better field position, and there's a % chance that you keep the ball where you have a better field position for yourself. You have state A with a 100% chance, and then there's a probability of state B or state C if your play is successful or not. And I put a lot of words up here, but I want to keep it very simple again, is that you're looking at this possibility of state A with 100% if you punt, and then you're looking at some sort of probability if you play of state B or state C. And what you really want to know, the question at the heart of this is the probability that you make it plus the value you have at state B, the likeliness of you winning the game, plus the probability if you don't make it times state C. That equals basically your probability of winning the game should you go for it. And you want to know, is that greater than the 100% probability of state A, which is if you punt. So do you have more likelihood of winning the game if you go for it or if you don't go for it? One choice, many outcomes. And the way we're going to break this down is say, this is really complicated math. And so if you ask people and you poll for it, there's a couple things you can do to make it so people have interesting responses. But ultimately, what you're just getting from them is whether or not they think it's a good idea. We care about that. That's something we care about, whether or not fans think it's a good idea. Whether or not they make it, this is something we use prediction games for. It's a very complicated thing, but if you break it down the right way, you can actually get some good answers. And then whether or not it actually was a good idea, we go back to the fundamental models and we go back to the math. So let's run through this real quickly because I know we're already late. Polling. This again, looking at the 2012 election, you have in black on the top, this is aggregated from all the best polling companies in the world that are working in the US elections, and this shows the state of the election, the two-party Obama support at any given time, and red is our polling that we ran on Xbox about the election. We just let anyone go in and answer who they were going to vote for. Of course, that red line is like any typical online poll, it just looks like garbage, and it has absolutely no meaning, right? So, but fortunately, we know something about their demographics. And we know something about their demographics, and allows us to run it through a program which we call Mr. P. Affectionately, it is a multi-level regression with post-stratification, and it makes things look really cool. And what it does is it basically says who came to the poll on any given day, how should we weight you? And when we weight you properly, we see this from all different states, and we've seen this in sports, we've seen this in entertainment. We know that we could take this unrepresentative polling, we could actually make it represent. And one of the coolest things we found out when we did this thing, which is most relevant to sports here, is that we found out is that a lot of the movement in polling in the course of an election cycle was when the Democrats were doing badly, Democrats did not show up and take the polls. And when the Republicans were doing badly, Republicans didn't show up to take the polls. And what that means in sports is that if there's an exciting moment and one team starts moving forward, their fans are going to start engaging more, and you need to account for that. Otherwise, your polling is going to represent enthusiasm and nothing else. And so understanding that, we also know that beyond the aggregation method, we also know we can ask the right questions. So in the same group of people, same unrepresentative group of people, we asked them who they expect to win, who they expected to win their state. And despite the fact that the poll itself looked like this, the same people on the same day pointed in the correct direction for 51 out of 51 electoral college elections, 51 states. So if you ask the right question, you actually get the answer you're looking for. Justin and I worked with ESPN to do this for basketball, and we were the stat geeks, I guess. And we won, right? So asking the right questions to the right people, we were able to show what was going to happen in the NBA playoffs, and we actually asked fairly complex questions. The problem is that this question and this question are actually pretty hard to answer with low latency, with a couple of seconds on the clock, but they definitely work in the right environments. So we're going to focus in on this decision to punt or play. And you ask a question like this, so should they go for it? So this is a polling question, how would it look? And you're going to get a result. And the first thing you're going to do is you're going to correct the result. This is all hypothetical, of course. Sorry, this is just to show you what it looks like. You're going to correct the result. And when you correct the result, you're going to get something. We know we can get something that's absolutely representative of the group that you want to represent. But more importantly, we can also break it down. The way that we run polling numbers with the background information we know, we could break it down to the groups that you actually care about, the actual question that announcers would want to turn back to people, which is what are Seahawks fans saying, what are Broncos fans saying, and what are neutral fans saying, which we expect to be completely different. And that's why the aggregate raw results look so weird, is because it's being driven by who's actually turning up, and when you break it down, you can get something that's actually useful and meaningful. So polling can help control the question. You can help correct for the demographics. When you do so, you can provide some really domain-specific sentiment that you actually care about. What should the coach do at a given time? But it's really going to be prediction games that answer what they should actually do, not what the fans say they should do. And as Justin mentioned, 33 million Americans play fantasy football every year. But what we're going to talk about here has two main differences. It's going to have a lower latency, and it's actually going to provide public consumption value versus being a private game among friends. This is probably hard to read. This is the results of prediction games that we were following for the 2014 Oscars, which happened last night. There's 24 different categories. Some of them are very prominent. Some of them are quite technical and not very prominent. And since you probably can't read it, so I just highlight the winning ones. So these are the ones that won. So 21 out of 24 categories, we were pointing in the correct direction. We were very well calibrated, which meant that we had an 86.5% likeliness to win for the top contender in any given category. In expectation, we thought we'd get 21 correct, and we did. And we're very excited about it. And this shows something about the value of prediction games, which is that they do this really awesome job in two things. Number one, they help answer idiosyncratic information. So as Justin said, you could take a fundamental model, and from that fundamental model, you can make a baseline prediction if the world is stable, if you have the data. But something like who's going to win production design or makeup in the Oscars, if I had all the data in the world about the Oscars, or about movies, anything, I don't think there's a data point that solves whether or not a movie has great makeup versus other movies or great production design versus other. It's a very idiosyncratic thing that's hard to get a data point for. Similar to that guy's not looking that healthy in the fourth quarter of a football game, or that tennis player looks like he's limping a little bit. We don't have a way to put that in a model. And that's where the wisdom of the crowd steps in prediction games. Similarly, it helps gather dispersed information because there's incentives that get that random guy who actually knows a ton about sound mixing versus sound editing and can tell you that one movie is going to win sound mixing and another movie is going to win sound editing. That's a really rare find. You need to incentivize that person to show up and answer your questions. And that's what prediction games do. Furthermore, we're able to run, and we've run these with several tests inside and outside of Microsoft, in which we worked on combinatorial markets. And the only thing you need to know about is that in the 2012 election, we let people bet on any outcome of any Senate race or presidential race or combination thereof. So that's who's going to win in any state in a Senate and presidential election. That's 2 to the power of 84 different outcomes. And we kept everything consistent. And that's the really tough work of that, was keeping everything consistent. And that's part of what I'm going to explain right now, is part of the value of being able to ask part of the question about should you go for it in fourth down and making the whole picture actually work together. And the one last thing I'd say before I jump back in and finish with the football example is this, is that while people can provide a lot of idiosyncratic and dispersed information for you, you can't challenge them too much when the clock is on. This is from a Kansas versus Ohio State basketball game, and it was in a tournament. So this was the semifinals of the tournament. And so there was a market running, there was a game running for the game itself, and then one for who was going to win the tournament. And the game itself is in red, and the tournament is in blue. And what happens is everyone was putting a lot of important information into the tournament one, which is, think about it, that's round 2. Then the game started, and everyone left that game and started just focusing on the game that was going on, the game that was the semifinal game. And then after Ohio State had won, or Kansas won, they went back into the tournament market. People have a limit to how many things they can compute in their head at one time, so you need to focus them in. And so we focus people in here at whether the play would be successful. And the nice thing about this is that you start with the fundamentals, and then you say, allow you, the crowd, to provide us the idiosyncratic information. How is this different than any other fourth down that our statistics have run? And we see time and again when we do this, the nice thing is, with the improper incentives, the Seahawks fans, the Broncos fans, and the neutral fans all look the same. And they provide extra information. So they can provide extra information, and it's not need to be debiased by who they're rooting for. You can take baseline probabilities from fundamentals and you can improve them. And that's really the main takeaway from this, is that you get a lot of extra stuff together. And since Justin started with this, I'm going to kind of end and pull back to say, everything we're talking about here is talking about innovation to overcome the low latency problem, making things more relevant to the people who are actually following this stuff. And we haven't talked about it, I didn't really go into it here, but you could also make this personal. It could be the question that people care about, could be showed and displayed on it. And this can provide both the producer sending more information to the consumer sending really meaningful information back to the producer, and these games and the forums allow consumers to engage with consumers. We talked about 4 different types of data, and it's the aggregation analytics that allows us to make it relevant and meaningful, as well as possibly personal to people. It's the infrastructure that creates this lower latency that's key, and it's this high level of engagement that creates this virtuous cycle where engagement leads to more information leads to more engagement. What would something like this look like? This is just, as Justin said, this is totally off our heads. This is not necessarily going to be built at any given time, but the types of things that can come from it. You have in the lower left-hand score, you can have how much people are talking about the game itself, or possibly some topics that are being covered. You can see, how much the fans say that people should do something at a given time, and the data can tell you whether or not it's a good idea or a bad idea. And then you have the engagement on the right side, which is going to be, things that are very high latency, low latency, things that happen fast, and some things that are left up for the whole game. And also, this is the exact same experience on a second screen as a first screen, because right now, people who are running that first screen, they're losing all these people to the second screen, because who watches any of this stuff anymore and doesn't have a mobile or a computer or something in front of them? And so the whole idea that advertisers have that you're held hostage to the live event, it goes the way when everyone's not really watching the live event all the time, especially during commercials when they have their head in a different screen. If that other screen is actually forming a companion piece and maybe has ads that are duplicated on both sides, then you have an experience where you really have them hooked. Because they want to have a full engagement experience, they just don't have an opportunity yet, so they go to different websites or different places. This is, exactly the same in politics, entertainment, economics, business. There's nothing we talked about here, absolutely nothing, that's not completely relevant to live events or even more, much more even varied in all of these other disciplines. All the different sports, all the different types of entertainment and politics, it's really all the same from the back end when you look at this stuff. So thank you guys very much, and I guess we'll take some questions.